This is a complicated problem. We're going to start talking about the domains of composite functions. And to do that, you have to at first remember what causes a domain restriction. Well, there's two things. You can't square root a negative. Okay, that's number one, not allowed. Number two is you can't divide by zero. Okay, you're not allowed to divide by zero. That's number two. The first one leads you to imaginary stuff. The second one leads you to infinities, neither of which is a real number, so we don't include it in the domain. So I'm going to go through each one of these guys in the examples below, the domain of each one. And if there's one in particular that's got you stuck in this problem, I want you to just zip forward to that, because this is a little bit of a longer video. So 1 over square root of x. What can't I do? Okay, I'm not allowed to divide by 0. Okay, so that, well, let's back up. Can't square root negative. Okay, what that causes is x cannot be negative. And the other part of this is the 1 divided by something. Okay, that says x cannot be 0. And here's the reasons why. If x is negative, that's obvious, right? The square root turns into an imaginary. If x is 0, square root of 0 is just fine, right? You get 1 over 0. But it's the 1 over 0 that becomes a problem. So I can't have x equals 0. I can't have x equals negative. That means x can only be positive. Now, this isn't interval notation, so you're not done yet. You have to write it this way. 0 through infinity. Okay, that's your actual answer. They mean the same thing, but this problem wants everything in interval notation, so there we go. Next example, which is 1 over h. With this one, it should be familiar from our unit on rationals. What are the things we can't do, right? I don't have to worry about square roots, but I still can't divide by 0. So that means x plus 2 cannot be 0, which gives me x cannot be negative 2. It also tells me x minus 1 can't be 0, which gives me x cannot be positive 1. Those are our two domain restrictions, this guy right here and this guy right here. So the way we write that in interval notation is the following. It's going to get, let's see if I can move this over a little bit. There we go. It's going to give me this. All the numbers except negative 2 and positive 1. So I start at negative infinity, and I go to negative 2, hop over that one, I hop over the domain restriction like a speed bump, and I go to 1. Hop over that, and then coast is clear until infinity. All right, so that's my domain for this one. All right, now things are getting a little more complicated. P over h is just equal to what I've written here. Okay, if you're not seeing that, I want you to take a little pause on the video and prove that to yourself. And now think about the things, the domain restrictions here. Okay, for one thing, x can't be 0. Okay, I'm not allowed to divide by the square root of 0 any more than I can divide by 0 itself. So I can't have x equals 0. I can't have x equals negative 2. I can't have x equals positive 1. Okay, those were from the rational function earlier. But I also can't have x being negative. So it's like I'm combining all the domain restrictions we've talked about so far. I have 4 domain restrictions now. And if we think about this as a number line, it may be easier to see how I'm going to combine these things. I'm going to put circles around the ones that are no good. Okay, so plus 1, that's a domain restriction, no good. And 0, that's a domain restriction. And negative 2 is also a domain restriction. And when I get to the negatives, like all the negative numbers, look at what happens. I'm ruling out all the negative numbers, like negative 5, negative 3, okay, negative, all these things, all these guys are just bad news. So the only thing remaining for me is numbers above 0, positive numbers. So the domain looks like this, 0 through infinity on this one. Okay? Next example. The domain of a composite function. We talked about this in class, but what you have to deal with now is 2 sources of domain restrictions. Okay? You have the domain restrictions from your inputs. That's let's see, h of x, that's the input. It's what's getting put into the other function. And the domain restriction of the output. That is p of h of x. Okay, so for clarity, I wrote down h of x right here. And I have p of h of x right here. So are there any domain restrictions from h of x? We'll take a look at it. It's just this thing. There's no divided by zeros. There's no square roots. So there's no domain restrictions, meaning there's nothing to worry about, at least as far as the input is concerned. Now, the output is a completely different story. Think about the domain restrictions that would cause you to divide by 0. Okay, x can't be -2. That much is clear. X can't be +1. We've talked about this one before. Now, what does that square root do? That means something else. That means x plus 2 times x minus 1 cannot be negative, which is a little different than saying it can't be 0. Saying it can't be 0 got us these things. Saying it can't be negative, well, that's a whole different problem. I think we gotta graph this one to figure it out. So if you were to graph that polynomial, x plus 2 and x minus 1, you should remember how to graph things. Here's my x-intercepts. Okay, it's a positive even function, right? Remember the whole multiplicity thing and end behavior that we talked about a while ago? So it's going to look like this. This is your function. What's this thing? This is h of x. So where is that negative? Well, it's this whole area. This is all domain restrictions. That whole area is forbidden, which means x cannot be in there. So I have to say this is my domain. X has to be less than -2, or x has to be greater than +1. Okay, you can't actually have -2 or 1 as values because then you're dividing by 0. You can't have anything in between them as values because then you're square rooting a negative. So here's how you would write that domain. You'd say -infinity to -2, not including -2, union everything from 1 to infinity. Okay. Last one. This one is actually a little easier. Again, you have two sources of domain restrictions. I'm going to do this in purple now. Two sources of domain restrictions. You have inputs. This one is p of x. P of x is your input now. And you have your output, which is h of p of x. Okay, and I've written them up here for your convenience. So take a look at p of x. That's this guy. What are the domain restrictions? Well, we've talked about this one already. X can't be 0, and x can't be negative. So two domain restrictions there. How about the output? If you take a look at this function right here, okay, pause the video if you need some time to figure out why that is actually the function, the composite function h of p. And now look for domain restrictions. Am I dividing by 0? Sure. I don't want to do that. I have this function right here. 1 divided by x, not allowed. X can't be 0. I also have 1 divided by square root of x, which means x can't be a negative. And it also can't be 0. So I have 4 domain restrictions here, but they're overlapping, right? They're duplicate domain restrictions. So all that means is you have one of these situations again, where you can't have 0, you can't have negatives, so all you have left is positive numbers.